So today we start the first of 2 units on circles. So at this point we have 3 tests remaining, 1 on solids and 2 on circles. Okay. Today is primarily learning terminology. You have to know the vocabulary in order to do this unit. It's not a hard unit. I think most people find that it's easier than what we're doing currently with solids. Certainly less involved. But if you don't know the vocabulary, it gets bad. Okay? So, some terms that you may have learned in other math classes before now, or may not. Either way, got to know these. First of all, a chord is a segment that has its endpoints on a circle. Notice it is a segment, not a line. So here's an example of a chord. It's a segment that has both endpoints on the circle. A secant is a line, so not a segment, that intersects a circle in 2 different points. So you draw a line through a circle, that's a secant. It's going to go through. A tangent is a line in the plane of the circle, so that just means it's drawn on it. It's not like going through the piece of paper. That intersects the circle in exactly one point. That's called the point of tangency. So it just barely skims the circle. It touches only in one point, not in more than that. So that's a tangent, and this point is called the point of tangency. Part of your assignment today, which will be due on Friday, is something like this. They'll give you a diagram and they'll say identify each line or segment that intersects circle P. It doesn't matter where you start, but you have to list all of them. So let's start. We start over here, for example, segment QR. It's a chord. It's a segment, and it has both of its endpoints on the circle. What about segment QP? It's a radius. Now, when we get over here, there is a segment in the middle of this line. We need to talk about both of them. So segment ST has 2 different names. It's a diameter and it's also a chord. In fact, some textbooks define a diameter as a chord that contains the center of the circle. Okay? Now, what if we were talking about this whole line? We could call it line M. Or we could call it line ST. We haven't done that in a long time. Either one is fine. It goes to the circle in 2 different places. That's a secant. Some people say secant. I don't like the way that sounds. What's like, do you say pecan or do you say pecan? Yeah, one of them makes your skin crawl, doesn't it? Yeah. I'm the same way with secant. I'm like, All right, now, in addition to that line and that segment, there are 2 other segments that intersect the circle along this line. Segment SP and segment TP. What are both of those?
Radius.
Yeah, the plural for radius is radii.
Can you say radii?
Pardon?
Can you say radii?
If you want to show your ignorance, certainly. Why would you purposely mispronounce something?
Radius has some hard to remember in radii. And when I read it, I just say radii.
There's two I's though. Radii.
Okay, yeah, that makes sense.
And then there's one more line, line L.
Tangent.
It's a tangent. By the way, we will use the word tangent two different ways. We'll talk about it like, which line is a tangent? This line is a tangent. But we'll also use it like this. We'll say line L is tangent to the circle. So we'll use it both ways. Okay?
What's the difference?
One is a noun.
Oh, so I thought it was like a different like line.
Oh, no. It's just a different way of saying it. It's a different part of speech. Okay, occasionally that annoys people, at least at first. Okay, so you should be able to do that, be able to identify all those pieces. All right, let's go on. All throughout the year, we've talked about objects that were congruent. We started off the very beginning of the year talking about how if you put your hands palm to palm, basically, and I know it's not perfect for anybody, but basically one hand exactly covers the other. That's the idea of two objects being congruent, that if you put one on top of the other, it would exactly cover it. Okay? So in order to be congruent, we said that you had to have two qualities. They had to be the same, if I remember, size and shape. They have to be the same size and the same shape. Proportions has to do with similarity. Okay? Well, all circles are the same shape, so that's not an issue. We just need to check to see if they're the same size. And the easiest way is to check to see if their radii are congruent. Two circles are congruent if and only if they have congruent radii. In other words, these two circles are congruent if these two radii are congruent, and the other way around is also true. If these two circles are congruent, these two radii are congruent. That if and only if means that it works in both directions. Okay, we won't do very much with this, but it is a term that you need to know. Concentric circles. In Spanish, what does con mean? Means with, right? And when you add the ick at the end of this means with the same center. Okay? So the word actually tells you about it. It's two circles that have the same center, like a bullseye. Okay? Notice on this that when we name the circles, we'll name them. We've talked about this before, but remember, the symbol for circle looks like a circle with a dot in the middle of it, so it doesn't look like an O. Now, in addition to having a line that's tangent to a circle, you can have two circles that are tangent to each other. Notice these two circles only touch in one point. These two circles only touch in one point. These are called internally tangent circles because one circle's inside the other. And this is externally tangent circles. It's a little bit like if you've ever looked at something that has gears in it. Gears typically are either externally tangent, where one rolls around the other one, or they're internally tangent, where one rolls around the inside of the other one. Okay, these are less common. Most of the ones that you see, the gear teeth are on the outside, but you can actually have one with the teeth on the inside, where one just rolls around and around on the inside of the other one. Once upon a time, hello, we would talk about, at this point, have any of you ever even seen a spirograph? Spirograph. No? Okay.
Is that like a DNA soap?
No, that's a helix that spirals. It was a toy that kids played with, and what it had is it had these different size gears, and it had a hole in it that you put your pencil in, and as it rolled around, it made these cool patterns.
Oh, yeah, I know what it is. There's definitely a name.
And you could do, inside the circle, or you could do it outside the circle. That's the same idea as internally tangent circles versus externally tangent circles. All right, so again, all of that is just knowing the terminology. We're going to have a couple of theorems today. This is the one that we use more often than anything else, is that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. It's a lot of words for an idea that's pretty simple. If you've got a line that's tangent and you draw on the radius to that point of tangency, it's always going to be a right angle. Now, why does it have to be a right angle? Well, because if it wasn't a right angle, so if it looks something like this, would it be tangent anymore? No, it would be secant. It intersects the circle in two places instead of just one. So if it's tangent, it's got to make a right angle. So let's do some example problems with those. Go on to the next page, please. All right, in each diagram, it says segment KH and segment KD are tangent to circle C. We want to find the measure of angle K. All right, so I know that this angle has to be a right angle. And this angle also has to be a right angle. What do the angles in a quadrilateral, not a triangle, but in a quadrilateral, always add up to? Do you remember? 360. And the reason why is because if we drew a line across here, for example, we'd have two triangles, and each triangle adds up to 180. So what I have here is I've got 138 plus 90 plus 90 plus the measure of angle K has got to be 360. Let's see, that's 218 plus angle K is equal to 360. So the measure of angle K is
42.
how much?
42. 42.
Oh, this is 318. I was like, something's not right here. That's 42. Thank you. Any questions about that? We can also do this as an algebra problem. Here, again, both of these have to be right angles. So I've got 3x plus 7x plus 90 plus 90 is equal to 360. So grouping the like terms, that's 10x plus 180 is 360. So 10x is 180. Divide, we get that x is equal to 18. So the measure of angle K is 3 times 18, which is 54 degrees. Everything okay?
Yeah, I forgot about the last part. The measurement.
Yeah, you do have to make sure you answer the question.
Yeah, I was like, oh my god, I got this in the bag. And
All right. The only other theorem we have today is this one. If two segments are tangent to a circle from the same exterior point, then those segments are congruent. I had a student years and years and years ago who called that the ice cream cone theorem. So if the sides of the ice cream cone weren't the same length, your ice cream would roll out. And I'm like, okay, if that helps you remember it, that's fine. I had another student who called it the bird beak theorem because it looks like, one of those, you ever do those where it says how to draw a bird and you start with a circle and do this, and it was always horrible. Pardon?
The step-by-step ones?
Yeah.
Those are always fun.
So real quickly, let me show you why this works. Please just watch. So let's say that I don't know these are congruent to start with. Okay? But I do know that they're tangent to the circle. So that means if I draw in a radius to the point of tangency, what is it going to make?
Right.
A right angle. So I know that's a right angle. And again, you don't need to draw this. And I know that's a right angle, right? Okay. I'm going to divide this into two triangles. In this circle, what do I know about these two radii? They've got to be the same, don't they? So they are, what's the word for that? They're congruent. So these are congruent to each other. The reflexive property lets me know that this is congruent to itself. And then, again, back to first semester, these two triangles are congruent by, anybody recognize that?
Or side.
Side angle's not a thing. It's not side angle side. What was the other one that you said?
I can't remember the name, but I know it's HL.
Hypotenuse leg.
Yeah.
Yeah, it's hypotenuse leg. So these two triangles are going to be congruent, which means that these two pieces have to be congruent also. So that's just the why it works out. I think it's pretty easy. You look at it and go, yeah, those look the same length. All right, so let's do this one example problem. HK and segment HG are both tangent to circle F. We want to find the length of HG. Well, I know that these two are going to be congruent to each other. So x over 4 is equal to x minus 6.3. And there are lots of ways that you can do that, but the simplest thing is to multiply both sides by 4, at least in my opinion. So that over here the 4's divide out to be 1, so that's going to be x is equal to 4x minus 25.2. Subtract 4x from both sides, and we get negative 3x is equal to negative 25.2. Divide both sides by negative 3. We have x is positive 8.4. Then be sure to answer the question. The length of HG is then going to be 8.4 over 4, which is 2.1. Okay, any questions? All right, so your assignment on this will be in the book. But right now, let's take the quiz.